Hi, this is Babar Hashim. I am a product manager at SoloX Technology America. Today I will be demonstrating how to add Wi-Fi capability to an NXP i.MX 6SoloX SaberSmart evaluation platform using our latest 802.11ac Wi-Fi SDIO module, the SX-SDMAC. The SoloX SX-SDMAC is a dual-band 802.11ac wireless LAN plus Bluetooth Smart-Ready SDIO module using Qualcomm Atheros QCA 9377 SoC. It supports single-stream Wave 2 multi-user MIMO that can attain maximum fire rate of about 433 megabits per second. Okay, let's get started. To complete the steps in this video, you will need to purchase the shown evaluation platform and the radio module. The i.MX 6 Series SoloX development platform and the SoloX Technologies SX-SDMAC radio card for evaluation, also called the SX-SDCAC. The SaberSD evaluation kit is available directly from NXP or through one of its authorized distribution partners. To purchase the SoloX Technology evaluation module, please contact SoloX or one of our distributors in Mouser, Future, or Arrow Electronics. The SX-SDCAC sample pack comes with an SX-SDMAC module in a card form factor. It includes an onboard antenna that is used as a default antenna. It also includes an optional UFL PCB Unitron antenna that we have certified the radio with. Once you've opened the i.MX 6 SaberSoloX evaluation kit, you'll find the following items: a universal power supply, USB cable, and most importantly, the i.MX 6 SoloX evaluation board. An SD card with an Android image is also shipped by NXP. This, however, is not required for evaluation. In addition to the i.MX 6 and the SX-SDMAC evaluation card, you will also need at least a 4 GB SD card and a PC with a USB port. We have created an evaluation image that contains a fully optimized and enhanced SoloX radio driver, security supplicant, and other evaluation tools. Please refer to the user manual for full details. This image can be downloaded directly from the SoloX website or by contacting SoloX Sales. Instructions on how to write this image to the SD card are available in the user manual on our website. Now let's start hooking things up. First, plug in the radio card in the SDIO 3.0 slot as shown. It is important to plug it into the correct port supporting SDIO 3.0 to get the full benefit of throughput. Next, we plug in the SD card that has a SoloX image installed on it in the SD card slot. Next, we connect the console cable that connects directly to the laptop via the USB port. Finally, we connect power to the SoloX board and turn on the switch. Now I'll be demonstrating how to enable the wireless interface through the laptop console and connect the i.MX 6 SoloX board to an access point and see if we can ping out to the internet. Once everything is connected and we turn on the power switch, the board powers up, initiates the auto boot sequence, and starts running the kernel. After boot up process is complete, which can take up to a few seconds, it should eventually ask for login credentials. As with all SoloX EVKs, login is root and there is no password set. Now we can see that we are in. Let's take a look around. You can see that in the root folder we have a script that installs the wireless LAN module. By default, this is not enabled, so we must install it. So let's go ahead and run that script. We now have installed the wireless LAN module. By typing iwconfig, you can now see that we in fact do have a WLAN 0 interface now available. Before we can do a network scan, we need to activate the wireless interface. This can be done by typing in ifconfig WLAN 0 up. Once we have the wireless interface up, we can now do a network scan by running the iwscan command to get a list of all networks that are available to us in our environment. Or alternatively, use the grep command to list all the network SSIDs that are available. If we run this command, we see we have about 4 SSIDs we can detect by our internal onboard antenna. Let's try to connect to one of these networks named Casa de Papel. To do this, let's go into the etc folder and look at the configuration file for the wireless security supplicant. In this case, I have already configured the wireless supplicant with the network credentials for the access point Casa de Papel. Once the configurations are saved, we can run the WPA supplicant. I'll just go back to my command list and find the command and run the WPA supplicant -b for background using the NL802.11 and using the supplicant configuration file in the etc folder. When I run this, among other things, we have now also successfully set the DFS region to FCC. You can see that the link is now enabled. Now, let's go ahead and run the DHCP server by the command ud hcpc-iwlan0. By running this, we get assigned an IP address. So, now by running the wlan0 link command, you can see that we are now in fact connected to the Casa de Papel access point. We see that the signal strength is really good at MCS7. This is because the AP is not an 802.11ac AP. The radio in fact has the capability to go much higher than MCS7, even to MCS8 or 9 rates. Last but not the least, let's now try to ping silexamerica.com to verify we are connected to the internet. You can see that we are now successfully receiving data. So there we go. We have boards now up and connected wirelessly to an access point, and we are streaming traffic between an AP and the SDIO SX-SDMAC 802.11ac client. Thank you so much for watching the video. If you have any additional questions or would like to discuss your application, please contact Silex Technology America at the information shown here. We would welcome your call.